Hi there, and welcome back to my laboratory. So, as a first electronics related video for me to come back to the channel, we'll be repairing an old machine that I have. Let me show you its box. This is the first, let's say, cordless tool that I got from my lab way back in the day when I still was dating my ex. And this is my cordless driver or drill, or call it whatever you want. This is an old Black & Decker drill, and its battery is really old. And after the years, the battery just cannot hold any charge. And as this guy can only be connected to the charger or to the drill is basically that. So I thought, hey, why not bring this back to life? And then I remember Great Scott made a video years ago about making some battery packs using a proprietary IC. So in case you guys don't remember, I am talking about this video right here, the My Power Bank Rivals commercial ones, and it's actually a really good video and goes into details about a lot of stuff, including using a specific IC to control a battery bank made from 18650s batteries. So recently I got a shipment of those. In case you don't know, these are 18650s and for some reason 32 high explosive. I don't know what that means. But these guys here are brand new batteries, not the ones that I scavenged from, old equipment. Let me show you its datasheet. So this right here is the datasheet from this specific 18650 battery. And 3.2 amp hours, and then you have the voltages, currents, maximum, and resistance. This was tested by a coworker of mine, really nice guy, and he just tested the batteries. They are actually up to spec. And here is how it should be charged or discharged, and then the rates, and then temperatures, and then technical drawings. Basically, you're gonna use this as a reference to configure the charging IC. And which IC is that? It's this guy, the IP2368. You may not be recognizing this guy. From Great Scott's video, you actually see this chip in a purple board. Let me show you its board. So right here, I have the package from AliExpress, and you have the purple board right here, and you can even read IP2368. This is the board you're gonna use to USB-C charge our battery pack. But as a battery pack needs a balance, this kit comes also with a balance board. So you connect this guy to a battery bank, and then with the balancer, we know we can just treat the battery as one single cell ideal battery, and then we charge it with the specific, IP2368 board. And before going for the chip and all the stuff, we need to actually make a battery pack using nickel strips. And nickel strips have some specific ratings. So I got the biggest nickel strip, I got the thickest one, but I still wasn't sure if that was enough. So let me check this very handy table that I have on my computer. So with this table you can see, this is ideally, at least I paid for, a pure nickel strip, guys on top in here, and it's a 0.2 by 8 millimeters, should be between 13 and 18 or 19 amps. I believe 15 amps should be okay. And my power drill should not draw more than 10 amps. So we are on the green with the nickel strips. So before going any more details about the IC, the video, I have to examine the power drill. Well, actually the power drill is fine. It works really fine. We need to examine this battery pack. What this battery pack does, what does it have inside, and we have some clues right here. You can see, nickel cadmium batteries, 12 volts. And as you know, nickel cadmium have roughly 1 volt per cell, so this should be 12 cells of nickel cadmium batteries in series, I hope. So let's open this up and check. And I forgot to specify before opening this up, this is the charger, it plugs to a 12 volt jack, and this guy only has 2 connectors on the side. The third one in the middle is empty. And the battery, it has 3 connectors, but the power tool doesn't. So I'm assuming they use the same modes to use with, lithium 2-cell series batteries, I'm guessing. But this is an older model. They use the same modes for a low quality battery. I really don't like nickel cadmium. So let's open this guy and see what you have inside. So here we have it, and I already cut one of the wires because I had to discover what this was before I start recording. You have another connector in here, which had another part of nickel strip. There you go. So you're gonna use this guy to solder a new battery pack. And here we have 12 nickel cadmium cells. And this is going to recycling because I have no use for old dead nickel cadmium cells. And that leaves us with an empty husk of plastic and a standard connector, which I can use to connect to the power tool without making any, adaptations. And as of course I'm going to use the USB-C charging IC, I won't need the, these 12 volts with a DC jack connector anymore. With this is going to be obsolete, and I'm going to just repurpose this for another projects. So just to simulate the size, I'm going to need, the internal volume. These batteries just fit very comfortably inside, so I'm gonna just use the nickel strips that I have in here and spot weld them together into a 3 series battery pack. So I just spot welded this guy and fixed it with, a little bit of Kapton tape to make rigidity. I have some, let me show you right here. Come on, focus. There you go. We have some spots in there, and now I have to prepare this based on the guides that I found on the seller's website. So as you can see here, you should just connect these cables. We're gonna have up to the gray one, or white in my case here, and then leave this one unused. And then on top of the battery have the charge and discharge positive electrodes. The negative one goes to the board, and then you have this battery negative one here goes to the battery. So we're gonna solder some wires and then get this all snugly into our battery case. So I actually did some stuff, and some trial and error afterwards. I've realized that this balancing board does not accept only 3 cells. It needs 4 for some reason. I don't know why. So I got a 4th cell in here, which totals 14 volts, and this guy right here actually tolerates 14 volts and 15 probably. So as the battery was dead anyway, I'm gonna move forward. So we have a 4-cell series in here, very close to shorting, to just keep this at place. And then you have the connector that you have on top of the battery pack. And if you slide this one up to the end, hold it like that, and then get your power tool and force in there. It works. So all we gotta do now is find a way to make this guy a whole thing on the battery pack, and after that we decide if we put the USB-C charging board on top or on the old charger. So let's see what is best for this board in here. So next day I was really busy on the first day of recording, and I wanted to redo the wiring. Remember that I welded the 3 batteries, one side by side, and then one on top. That was like a kludge. I was trying to, estimate the working of the board. Now that I realized, okay, this project is gonna work, I made a new pack. Let me just focus. So you have the board in here, like a square, 2 on the bottom, 2 on the top, plus and minus of the whole pack. And then here I have all the small wiring going to the taps, in between of the series. And now you have the connection to the original battery in here. and I just soldered, you know, the charging board for this pack. So the pack has an official, you know, body. Now it looks very, let me bring close to the camera. So it looks really nice actually. I'm not gonna lie, I'm really, you know, happy with the results. Spot welding was a first. Got to use my new machine. I can show you the machine later on another video, but you know, this is very compact and 3.2 amp hours and 4 cell series. I mean, respectable battery. So, does that work in this new format? Well, the 4 series is the same as before, and I can show it to you by now connecting, you know, and so the battery of course works, but will the charging work with this guy here? Let me just put in the center of the screen, and the answer is yes. I have a USB-C here for my charger, and that was my soldering iron, and you plug in here and you can see the LED is blinking. So remember before in the video, I don't know if I said or not, in the addition I will put the text confirming or denying, but there are some configuration resistors in the board that configure how many cells and capacity and all that. But as far as I know, reading the documentation, this one charges as constant current, constant voltage. So it doesn't matter the capacity and all the configuration. The only thing that changes from the configuration, all that, is the LEDs. As I'm thinking about putting this guy inside the, you know, the battery package, I don't care about LEDs and all that. The only thing that matters is that this guy works, you know, and charges fully. And for that, as far as I know, for reading the documentation, this guy will just work. But again, I have to test this. So I just want to show you the new battery pack in, you know, everything soldered and isolated. Really, really nicely looking. I'm not gonna lie, I'm really proud of this battery pack. And I glued with hot glue this guy here. So the socket here, remember in the beginning of the video, was like loose. Now it's fixed, ready to be connected to the power drill. And now I have this guy charging. So I'll just close everything and glue everything, put to charge completely, and then let's see how it operates on the next day when I discharge this guy, and then, you know, check if all the batteries are good. Because I've been testing this to make sure everything works, and I drained a little bit. So I'll just wait this board without desoldering anything if it will work with 4 series, 1 parallel battery of 18650s. So let's just glue everything together and then wait until, you know, next day, because I'll bring good news or bad news. So there you go, charging from USB-C, draining 60 watts, which is really impressive. And I'm gonna let this stay here for a while now that it's enclosed, and I in the end did not glue anything, just it fits right in and everything went really smoothly. Let's just hope the magic smoke doesn't come out, and I have a charged battery to test in a little while. So see you in a few seconds of editing video. So folks, we are back. I zoomed the camera in a little bit so you can get a closer look. This is the old battery of nickel cadmium, and it looks inappropriate. Let me put this down. Okay, so this is the old pack, bulky, and in the end only 1.3 amp hour. And now take a look at the new pack, you know, size comparison, you know, almost same height, but this one is much bulkier. Weight is almost the same, curiously, but I'm including the board here. But this guy is 3 amp hours. This is 1.3. So nickel cadmium, you're part of the past. Be gone. And here is my new assembly. Let me turn on the autofocus here. There you go. So you can see the board in here and the wire for the balancing of the cells. And you can see here I soldered 1 and 2, and 1 goes to the other side because these are the the plus, minus, and the middle cell. But the pack, I'm actually happy with the result. It looks really sturdy, really compact for 3 amp hours. This is actually a really good looking. I know I kind of went overboard with the Kapton tape, but you know, just make sure. I had some instances of small shorts and it's not a funny experience. So I made this, you know, this really crude, really orcish opening in the plastic, and it fits almost like this. And you can see here, I had to take one of the screw holes out so I can, you know, fit like this. And with this enough space, and see why I'm using Kapton tape to make sure things are not shortening, and you know, the battery worked. And now let me just get the multimeter and check the voltage, make sure that everything is fully charged up. So I'm gonna do my best not to short things up, because you know, not a cool thing to do. And battery minus is right here, and this should be 0 volts, and yes it is. Oh, let me get the multimeter on camera, right? Let's not be stupid. So there you have it, and no shorts please. Almost shorts. Yeah, that's a good level, almost 4.2. So cell 2, okay, cell 3, and cell 4, the top one. There you go. So all the cells are charged up. As I told you, this board is kind of overkill. The IP2368 is kind of overkill because it's meant to be a discharge board as well, so you can discharge USB-C. But I'm only using the charging function. You can use a cheaper board. So this protection board is really great, and I'm gonna probably get more. But the charging board, as I'm using power tools, you can get a cheaper one, you know, simpler, that only controls the charge, not the discharge, because the discharge comes from the battery, at least for simpler power tools. So I'm gonna just get hot glue hot and fix everything in place, assemble it, and you know, just do a last demonstration before I finish this battery and show you the extra stuff that you can do with the IP2368. You know, there's some configuration there that might not have the documentation. I'll be putting everything in the GitHub page. I always use a repository, you know, and I'll be using GitHub to get the documentation on the chip, on my, you know, battery cells, and you know, the documentation on all the boards and stuff. You can see on the link down below. So guys, just to finish this video, actually not finished, but you know, conclude the experiment. Here is the final module, the USB-C charging, and the pack is in here. Maybe you can see the purples. And then I use a little bit of hot glue, a little bit too much, but I like hot glue, better than smelling glue. So, does it work? Yes, it works. Actually works better than before, because now you have like, you used to have like 12 point something, now it has like 14, 15, you know, volts. And the protection circuit takes a little bit, but you know, it's bolted and it's easy to charge, and it's alive. I have my drilling, or you know, screwing tool again, and this is great. But before finishing the video, let me just explain to you how to use the IP20 something, 68 something, whatever, because it can be configured. So let me just, you know, show you the documents that you can find on my repository on GitHub, link down below. So the first image is the reference how to use the protection board, the balancing board, and this is very easy. You can see that I use all the cables that came with it, and then just solder wires and it's done. And I recommend doing what I did to simulate the position of the board and position of the cells, and then you can make the wiring look really nice. I think I nailed the look on my battery. I liked how it ended up. Then you have, this is the first image. That is the promotion from AliExpress, but it has a good, you know, reference. And then it talks about how to configure. You have the R7 in the board, is for the battery strings, the number of cells you have, and the R5 sets the capacity. So if you want to use the LEDs in here, you need to use to change these values, and they are proportional. So if you want, okay, these are fixed, but for battery capacity, you don't need to use 6.2 or 12.4. You can see there's a multiplication here. It's a multiple, so you can just do a proportion, you know, a rule of 3. And then you can find the resistance you need for example 3.2. Here you can see how to use R2 for different types of batteries and change R4 for the limits of voltage. I did not change that. It has a warning here if you go from 4 to 5 or 6. I did not. So this is an image that you'll find on the repository, and of course the table that references the nickel strips. I got the thickest one I could, and luckily my spot welder managed to kind of get the spots well done. So get the thickest one you can, because you know amps are your main factor, but also pay attention to your spot welder, you know, capacity. And lastly, but you know, probably the most important documents, you know, complete documents of the IP 2368. So if that small resume that you can find on AliExpress is not enough, I managed to find one version in English, so you can get, you know, all the information, especially when you come here to number of batteries, and it shows the pin, shows the number here, battery type and full voltage setting also here, and then charging current also here, and then you can have the fuel gauge. You see, if you use this as a battery bank, you can use this. If you only just to charge, you can ignore the board completely and just solder it and it will work. But if you use as a battery that you're gonna use to drain from it, you manage to get a fuel gauge that works relatively well. Basically use the output current to reduce the capacity, you know, measured, and then you blink the right LED. So that's it. You can also have an NTC in the board, and yada yada yada. So you can find all the documents in the repository. Thank you for coming to this video. First technical video of some others that I have planned. I hope you liked it, and very simple stuff. I just, you know, getting back in the saddle with recording and editing videos, and my autofocus, okay, there you go. I'm also, you know, on the final stretch of my master dissertation, so, you know, I'm gonna be quite busy in the next few days, but I will vlog the entire development process. I'm making a gimbal to, you know, measure, pinpoint some distances and mark some targets on the ground. So you're gonna use a Raspberry Pi, OpenCV, and some servos and a laser rangefinder, you know, basic stuff, but for my master dissertation. And hopefully by the end of the year I achieve the degree of master and I can work at the factory using a kimono. So until the next video, I hope you learned something or, you know, found this interesting, and I'll see you there. Bye bye.